You know, have you ever stopped to think about what's really going on behind the scenes when you hop on a video call or make a VoIP call? There's this incredibly powerful, kind of invisible engine that powers so many of the communication systems we use every single day. So the big question is, what is that engine? Well, that engine is FreeSWITCH. But here's the thing. It's not just some app you download. It's way more fundamental than that. Think of it like a foundational platform, a powerful toolbox that lets you build almost any kind of real-time communication system you can imagine. It's really the bedrock that so many other systems are built on top of. And when I say any kind of system, I mean it. Just look at the variety here. You can build massive enterprise-level phone systems, PBXs. You can build the WebRTC servers that make those video calls in your browser possible. Even those complex IVR menus, press 1 for sales, press 2 for support. Yep, FreeSWITCH is the super versatile engine behind all of that. Now, a lot of people make the mistake of thinking FreeSWITCH is just a SIP server, but that's just a tiny piece of the puzzle. The most important thing to get is that it's a complete communication engine. It's built to grab calls from all sorts of places, run some really complex logic on them, handle all the audio and video, and then connect deeply with other software. It does the whole shebang. So what makes this engine so powerful and so flexible? Well, to really get that, we need to peek at its architectural blueprint. We're about to dive into the 3 core design principles that are really the foundation of everything FreeSWITCH is and does. Okay, so these 3 big ideas are, first, a completely modular architecture, second, massive scalability, and third, a deep commitment to public APIs and integrations. Let's break each of those down, and we'll start with modularity. The best way to get your head around this modularity thing is to think of a car engine. You've got the main engine block, right? But on its own, it doesn't do much. You have to bolt on the parts you need, the fuel system, the turbo, whatever. FreeSWITCH is exactly like that. You start with the core, and then you only load the specific modules, the features, that you actually need. This makes it super lightweight and incredibly efficient. And this modular idea applies to everything, even the most basic features. So, for example, if you need to talk to SIP phones, you load the SIP module. Building a video chat app? Okay, load the WebRTC module. And here's the cool part. If you don't need voicemail, you just don't load the voicemail module. FreeSWITCH won't waste a single CPU cycle or a single byte of memory on it. It's total customization. All right, let's talk about the second principle, scalability. This is huge. FreeSWITCH was built from the ground up to grow with you. It doesn't matter if you're just running a tiny test on your laptop, or if you're building a huge call center, or even a massive carrier-grade network with thousands of calls happening all at once. The core architecture is designed to handle that load. So how does it pull this off? Well, it's all about smart, modern software design. For one, it's multi-threaded, so it can use every single core on your processor. It also uses what's called asynchronous I/O, which basically means it never gets stuck waiting around for the network or the hard drive. And it's event-driven, which lets it juggle a massive number of tasks at the same time, really efficiently. Okay, that brings us to our third and final principle, integration. FreeSWITCH was never meant to be this closed-off black box. Nope, it's designed to be a team player. The whole architecture is built to expose these powerful APIs so other apps can watch what's happening, control calls, and basically command FreeSWITCH in real time. And there are a bunch of ways to connect to it. The most powerful one is probably the Event Socket Library, or ESL, which gives you this incredibly fine-grained control over live calls. But you can also use standard web-friendly REST APIs, connect right over WebSockets, or even have FreeSWITCH pull all its settings from a database. It's this flexibility that makes it so darn programmable. Okay, so we've got these 3 big pillars, right? Modularity, scalability, and integration. But how does that all actually work inside the software? To figure that out, let's peel back another layer. We're going to take a quick tour of the internals to see how all the pieces really fit together. Right at the very heart of it all, you have the core engine. This thing is like the central nervous system and the heart all rolled into one. It handles the absolute basics, managing every single call, loading and unloading all those modules we just talked about, and this is super important, dispatching events. And that leads us perfectly into the events system. Every single thing that happens inside FreeSWITCH, a call starts, someone presses a keypad button, a user hangs up, it all generates a named event. This is brilliant because it lets different modules react to what's happening without needing to know anything about each other. It's what keeps the whole system so clean and decoupled, which is absolutely critical if you want to build something stable.
Let me give you a perfect real-world example. Okay, so a caller leaves a voicemail. The voicemail module has no idea what a SIP phone is. It doesn't care. It just shouts out a message waiting event to the whole system. Meanwhile, the SIP module is listening for that specific event. When it hears it, it goes, "Ah, I know what to do," and sends the signal to make that little red light on your desk phone blink. See? The two modules never talk to each other directly. It all happens through the event system.
So how do we actually tell FreeSWITCH what to do? How does it know how to behave? Well, we do that using XML. Pretty much all of its configuration, from the dial plan that decides where calls go to the SIP profiles that connect to your phones and providers, it's all defined in these structured XML files. You can think of it as the instruction manual that we write for the engine.
And last but not least, every single call that comes through FreeSWITCH follows this very strict, predictable lifecycle. It's called a state machine. So a call will move through a series of states. It starts as new, then it goes to routing, which is where FreeSWITCH figures out what to do with it. Then it's execute, where it actually does something, like play a sound, and finally hang up. Knowing these states is an absolute game changer when you're trying to debug something.
And A, this isn't just some abstract theory. If you actually look at the logs, you can see this state machine working in real time. Look here, in this log snippet. You can literally see the lines where the call enters state routing and then moves on to state CS_execute. Understanding this flow is what transforms a wall of confusing log text into a clear story about what's happening with your call. Okay, so we've covered a lot of ground. How does this all fit together? This brings us to the most important question, really. Why does any of this foundation stuff matter? Well, it's simple. It is the key to turning confusion into clarity. Because here's the deal. If you try to skip all this and just jump right into writing dial plans, you are absolutely setting yourself up for a world of frustration. You're going to struggle with debugging, the logs are going to look like gibberish, and you'll end up building things that just don't work the way you thought they would. But if you take the time to really get a handle on the modular design, the event system, and that call state machine, everything just starts to click. Suddenly, FreeSWITCH stops being this confusing black box, and it starts to feel like a logical, predictable, and unbelievably powerful tool. And that is the foundation for everything else we're going to build.